Hey, Mr. Howard here. We are doing some practice problems of solving logarithmic and exponential equations. So the first one here is 3 times the log base 8 of 512 raised to the x squared, and all that's equal to 36. So the first thing you need to do here is realize you can't have this 3 in front of the logarithm if you want to take it to exponential form. And you probably do want to take it to exponential form since the thing you're trying to get to is inside the logarithm. So let's see. To get rid of that 3, we could push it in as an exponent up here. Or we could just divide it out. So we'll divide both sides by 3, and it'll look like log base 8 of 512 raised to the x squared equals 12. Okay. Now if we convert it to exponential, it'll look like 8 to the 12th equals 512 raised to the x squared. I don't know if my calculator can handle this 8 to the 12. Let's see. Well, it does not like that. Let's see if we have a better option here. I don't like this at all. One thing we could do is kind of realize that I believe 512 is 8 to something. Excuse me. 8 to the 4 maybe? No. 8 to the 3rd? Yes. So we could say that this 512 is 8 cubed. And that would be 8 cubed to the x squared. And then we could rewrite both sides as 8 to the 12th equals 8 to the 3x squared. Well, that might be a lot of work, and there's probably a different way you could get here. But at that point, you've got like bases. 8 raised to something equals 8 raised to something. So those two somethings must be equal. So we can say 12 equals 3x squared. And if we divide both sides by the 3, we'll have x squared equals 4. Which technically gives me two answers. X equals 2 and x equals negative 2. And since this started off as an exponential, it's worth going in here and checking out and seeing if it makes this 512 to the x squared negative. Definitely it does not, since the 2 or the negative 2 would get squared up here. So both of these work. So you can run those through your calculator and see what happens. Okay. We may have saved a little time if we had changed the 512 to 8 cubed in the beginning. We could have used a different property, but it works out just fine. The other problem over here is also a difficult problem. Let's see here. It's 8 raised to the 3x plus 2, and that's equal to 7 raised to the 2x plus 3. So you've got two variables up here. Well, both of them is x, but you've got two things in the exponent position that you need to get out. So converting them to log form is semi-helpful, but not everything you need. So I don't know that I would try to convert this to log form, because then you put a x inside the logarithm and an x outside the logarithm, and it gets kind of funky. But what you can do is, if you have two things that are truly equal, as we have here, okay, the way they're given, then you can do the same thing to both sides. So I could take the log of the left-hand side, and it'd be equal to the log of the right-hand side, because it's a function and I'm doing the same thing to both. So that'll be log of 8 to the 3x plus 2, and if it's log base 10, then maybe our calculator will help us later, equals log of 7 raised to the 2x plus 3. Now the thing that's going to be helpful there is that exponent property will let us pull these exponents out front. So let's see what that looks like. It's not pretty, but it'll be 3x plus 2, and that'll be times the log of 8, and that'll be equal to, the other exponent comes out front, 2x plus 3, and that'll be times the log of 7. So we're able to get those exponents out in a place where we could work with them, which is in front of the logarithm. This is not my favorite type of problem, and it's one of the harder ones. If we try to get an exact answer out of this, it takes quite a while and a lot of work. So what I'm going to do is I'm just going to go ahead and abbreviate and take decimal forms from these two logs. and I'm going to take and keep my 3x plus 2, and from my calculator get my log of 8. Make sure you're doing base 10. That is going to be 0.9031, and that'll be equal to 2x plus 3 times whatever the log of 7 is, times 0.8451. So at that point, I can distribute these in here and start moving stuff around. Okay, so not a fun problem, but let's multiply on the left-hand side that 0.9031 times our 3x plus 2. So let's see. I will have 2.7093x plus 1.8062, and that will be, that looks a little messy, I can clean that one up a little bit. 1.8062. The right hand side, 2x plus 3 distributed throughout by the 0.8451. So let's see. That gives me 1.6902x, and then plus 2.5353. So then I've got 2x terms here to get on the same side. So now we're solving what we did from day one. We got 2x terms to get on the same side, and we've got 2 non-x terms to get on the other side, and then we'll divide out. So let's see what we get here. 2.7093 minus 1.6902. So on the left hand side I'll have 1.0191x, and that'll be equal to 2.5353 minus 1.8062, which will be 0.7291. So now this is definitely an approximation now, sorry. So now I'll divide out the 1.0191. So I'll divide 0.7291 divided by 1.0191, and as I divide both sides I will have 0.7154. Now if I go back to the original, it was an exponential, so it won't matter, but I can plug that number in and evaluate both sides. I can tell you, since we started rounding a little bit earlier there, they won't be 100% equal, so they'll be very, very, very close, but you'll be off some decimals somewhere down the line. So once we start rounding, we lose a little bit of that integrity. Alright, that's a difficult problem, and it's one that I kind of hate to see if I'm trying to get an exact answer, so in this case I'll just go ahead and do the approximation only.